All right, let's take a look at the ambiguous case. The ambiguous case is used when you're given an ASS, an angle side-side situation, or SSA, depending on your geometry teacher. All right, so in this case here, we are given a fixed angle. We're going to call that angle A for the sake of this formula here. So that's given. This side is dashed because I have no idea how long this side is. So this is this angle we're given. We are then given a side. We're going to call that side B. Then we're given another side, and right now I'm just going to kind of draw it coming down here. That's going to be side A. So there's the angle, there's the side, there's another side. The question is, where does, like, this angle is free to kind of open and close as much as we need. This side A here could be as long as we need it to be to hit this other side. And likewise, this dash side can be as long as we need it to be to make the triangle. So the only things that we know are the angle, this side, and side A. So to understand the ambiguous case, we need to know what the height of, I'll do the dotted line here, of the triangle is. So that's the measure that we are interested in. Okay? And that height is going to be perpendicular to the base. Now we did this early when we talked about the law of sines. In this case, h is equal to b times the sine of angle A. So again, when you're given a corner of a triangle, a side and an angle, the height is b times the sine of A. Now here are the four cases that work in this situation. First of all, if A is less than h and less than b. Now if A is less than h and h is the shortest distance from the end of side B down to the side down here, if h is as short a distance as there can be, and A is shorter than that, then no triangle results. So again, we're looking at the side opposite the given angle. If that is smaller than the other side, then we're going to jump in and we're going to find h. If h is larger than that side, or if that side is smaller than h, then no triangle results. If A is equal to h, so that means in this case here, that side A actually comes right down here at a right angle, then what you get is you get one right triangle. And we're going to use SOHCAHTOA to solve. Okay. Next, if A is greater than h, but still less than b, okay, then what we have is, and I'm just going to go ahead and erase this, A has the ability to form a triangle by coming out here, and we get this large triangle here, but equally, it has the ability to form a triangle by coming in here. And so what we get is we get an acute triangle, and we would get an obtuse version of the triangle. So let me go ahead and kind of outline these two different triangles. So one of them is this green one. And the other is this orange one. And in both of those cases, those two triangles have an angle in common, angle A side in common, side B, and this side here and this side here are both A. So we get two possible triangles. One last little thing here. In this case, this triangle is an isosceles triangle. In an isosceles triangle, the base angles are congruent to each other. This tealish looking angle and this angle in this second case, notice, are supplementary. They form a linear pair. So the two angles that are formed are supplements of one another. So when we use the law of sines, if I find that this angle is 80 degrees here in this triangle, then I immediately know that angle, this corresponding angle over here, would be 100 degrees. That's going to branch us off and help us find each of those cases. And we'll do that in just a moment. So let's come back here, look at these cases, and then I'll stop the video and we'll do some examples. So first of all, again, here are the first cases, so 1, 2, I did this one fourth and this one third. That works in an acute triangle, so angle A is acute. If angle A is obtuse, then it just becomes a simple thing. If A is smaller than B, then there's no way for it to reach the other side over there, so you have no triangle. And if A is greater than B, then you would have one triangle. All right, so there's going to be 3 examples we'll take a look at before looking at the area of triangles.